In this video, we are going to be looking at how to apply chain rule with Trigo functions. So the first example we are going to look at is y equals to cosine square 3x. Now first of all, let us interpret what cosine square 3x means. Cosine square 3x, even though we write the power here in the middle, it actually means cosine 3x times cosine 3x. So it's actually cosine 3x. The whole thing is raised to power 2. So I write it this way so that we can observe that this is a scenario where we need to use chain rule. Why? Because chain rule is used for expressions that look like this. So you have a fx, a function in x, raised to a power n. Therefore, in this scenario, we will need to use chain rule. So how do we use chain rule? We know that the first step is to bring the power down, and when we bring the power down and power decreases by 1, the function inside the bracket remains exactly the same. It doesn't change. Next, we multiply by the derivative of the function. So we differentiate the fx and we multiply by this derivative. So this is how we are going to apply the chain rule to this first question. So my first step would be to bring the power down. The power currently is 2. So bring the power down. The power will decrease by 1. The next step is to differentiate whatever is inside this bracket and multiply by the derivative of that. Now what do we get when we differentiate cosine 3x? Differentiating cosine gives us negative sine 3x. However, when we differentiate Trigo function, we also need to differentiate the angle. So differentiating 3x will give us 3. So we need to multiply by a 3. Okay, so do recap. Differentiating cosine 3x will give us negative 3 sine 3x. The 3 comes from differentiating the angle. So in short, the answer would be negative 6 cosine 3x sine 3x. Now we can leave this as our answer unless the question requires the answer in a particular form. Let us now try question 2. Question 2 wants us to differentiate tangent square negative x plus 2. So again, I'm going to write this as tangent negative x plus 2, and the whole thing is raised to power 2. Now I prefer to write the equation like this first so that when I'm using my chain rule, I will not get confused as to what is the fx. So fx is just tangent negative x plus 2. The power 2 is not part of the function. So if I write it this way, it's clearer. Now let us do the differentiation. First step, I bring the power down and then the power decreases by 1. Whatever is inside the bracket remains exactly the same. Next, I can differentiate this and multiply by that derivative here. So what do I get when I differentiate tangent? Differentiating tangent gives us secant square. And when you differentiate the trigo, the angle remains the same. However, when we differentiate trigo, we also need to multiply by the derivative of the angle. Now the angle here is negative x plus 2. When we differentiate that, you will get a negative 1. So we need to multiply by another negative 1. So final answer, we can now multiply the coefficients together. 2 times negative 1. And then tangent times secant square. So this would be the final answer. Okay, so in short, the strategy was, the first thing to do is to bring down the power. So we deal with the power first. Okay, the second step was to deal with the Trigo function. So for example, for the first question, cosine, when we differentiate, we get negative sine. So the second step is to differentiate the Trigo function. The next thing we had to do was to differentiate the angle. So that's where this 3 came from. So we need to differentiate the angle. So for chain rule involving Trigo, there are 3 steps. We deal with the power first, then we differentiate the Trigo function, and then we differentiate the angle. So let us finish up with the question 3. So similarly, I'm going to write this as sine 2x minus pi, the whole thing raised to power 3. So when I do my differentiation, I will bring the power down and the power will decrease by 1. However, the original function will remain exactly the same, sine 2x minus pi. So now you will differentiate whatever is inside the bracket. So I think that's why it's helpful for us to write this power outside, because when you are differentiating the Trigo function, this power 2 has nothing to do with this differentiation. So we just differentiate the Trigo function. What do we get when we differentiate sine? We get cosine and the angle remains the same. And the last step, differentiate the angle. When we differentiate 2x minus pi, you will get 2, so you multiply by 2. So in this case, the final answer, 3 times 2, then we have a sine square 2x minus pi and a cosine 2x minus pi. So this is how we differentiate Trigo with chain rule.